So you're looking at the wiring setup of solar panels and you're considering series, parallel, or a combination of the two. And you're wondering what kind of effect it would have on the overall power output, on the efficiency of the system, what would happen if you would have partial shading on some panels, or during low irradiance situations, such as at the start of the day, the end of the day, or during heavy overcast. Now, in this video, I will give you the answers to those questions in as simple as possible way. So let me start by introducing myself. My name is Jesse. I am a renewable energy engineer. I have run several companies in the design and installation of battery-based off-grid solar energy systems. I have held the position of energy officer for the United Nations, and I founded the company Solar Solution, through which I share my knowledge and expertise through videos such as this one, online articles, and I provide personal direct support through services on my website. I'll present you the information in 4 different sections. We'll discuss the power output and overall efficiencies. We'll look at low irradiance situations, such as during overcast. We will discuss partial shading on panels and panel sizes. And please remember, in order to keep this video short, I'm assuming that you are working with MPPT solar charge controllers. If you want to know more about this, I have different videos that can educate you in this topic. The first section, what is the effect on your overall power output and your system efficiency if you'd go for series or for parallel? Now, assuming that you have made the right choices regarding your material, regarding the wire sizes, the panels, the way that you installed your panels, etc., and then assuming that there's perfect sun conditions, then it doesn't really matter whether you install them in parallel or series. Both systems will have the same amount of power output, both systems have the same amount of energy efficiency. Now the story is a bit different during low irradiance. So these situations can occur during heavy overcast, during sunrise or during sunset. So when only a small amount of sun power hits the panel, it only creates a small amount of voltage. Now the solar charge controller needs a minimum amount of voltage in order to operate. If you would connect your panels in parallel, the voltage would not increase. But if you connect your panels in series, under low irradiance situations, the voltage necessary in order to operate is reached much earlier than compared to with parallel setup. So partial shading is a completely different story. So just to make sure that we understand each other, partial shading is when part of the solar panel is shaded by an object such as a tree or a bird or a mast or a vent, doesn't matter. But part of the solar panel is shaded. Now, in order for you to understand this topic properly, I want to explain 2 things. The first thing is that a solar panel is made out of all identical solar cells. The solar cells are those black bluish squares, which are all connected in series in one long string throughout the panel. Now, if shade would hit one solar cell and that cell would now perform less, let's say it performs 50% of what it could do, all the other cells, so the complete panel, will now produce at 50% of its capacity. Even though the rest of the panel may receive full sun power, the whole panel will be dragged down by this one cell. Now here comes the second point. Because some smart solar people have figured out that they can kind of fix this problem by installing bypass diodes in the panel. Now what these bypass diodes do is that if part of the panel receives less sun, they kind of cut out that part of the panel, so that part will not produce any power anymore, but the rest of the panel will still perform at 100%. Okay, so now that you understand this, I can explain to you the difference in performance between systems that have their panels wired in parallel or wired in series. For parallel connected systems, if you have partial shading on just one panel, that one panel will reduce its output according to what I've explained to you before, while all the rest of the panels will perform 100%. For solar panels in series, if partial shading occurs on one part of a panel, all the panels together, their output will be reduced. Though, if the reduction gets to any significant level, let's say 5 to 10% reduction, the bypass diode will cut in. And if it cuts in, only that part of the panel will be left out. The rest of the panel plus all the other panels will now perform at 100% again. So with this information in mind, I now suggest that you look at your specific setup and analyze what kind of partial shading might occur frequently, and then decide which wiring configuration is the best for you. So let me give you an example. If you would have several rectangular solar panels, and you connect them all in series, and they would be installed on a mobile setup such as an RV or a boat, you would typically want to align the shade figure of your vents, your air conditioning unit, your mast, your flagpoles, etc. You want to align that shade figure with the length of the solar panel. Now this would make sense because the shadow would only hit part of a solar panel, and if bypass diodes are installed, then only this part of the panel will be left out, or if not, then only this solar panel will reduce its output and not all the solar panels together. Okay, so this brings us to the last topic regarding panel sizes. I'll give you 2 tips. The first tip is that if you want to build your resilience against partial shading, you want to have your panels as small as possible. This makes sense because if you would have partial shading on one panel, and if you have your system set up in the right way, all the other panels will still perform at 100%. The second tip is for those of you who end up with one large panel or with several large panels connected in series. If you would have more bypass diodes, your system would be more resilient against partial shading, because if only a small part of a panel gets partial shading, the bypass diode will kick in, only that part of the panel will be cut out, and all the rest of the panels will perform 100%. Okay, so now a question for you. If there are other topics that you'd like to learn more about, let me know in the comments below, and I'll use this as inspiration to provide more videos for you and for others. And of course, if you liked it, I'd really appreciate it if you can give me a thumbs up. Kind of keeps me motivated. And that's all for now, so I'll see you in the next video.